Hello Abaqus user, welcome to Abaqus Acumen for quick and sound learning. In today's session we are going to do a crash problem. So like aluminum square tube with 300 millimeter length hit by steel block with 25 meter per second velocity, and then you can see how the crumpling zone happen in around 1/3 area. I'll also do one thing. I'll quickly take a section cut here. So now you see how this is contact is happening. So it's buckle first fold, then it's come in contact with another. So it's because of this additional contact the stiffness of overall structure increase, and then block doesn't have much velocity left within it, so it just rebound it back. And I can take a clipping plane, and then we can also plot what is the stress. So how is the stress generated in this? So we'll try to solve this problem. So let's go to drawing board and understand what we are going to do. We are going to do a simple crash problem using Abaqus Explicit, but we are going to do in Hypermesh preprocessor. So preprocessor for this problem we are going to do in Hypermesh. As I mentioned, it is like a 100 millimeter by 100 millimeter aluminum square tube, 300 millimeter length. We have end caster condition at one end, and then there is a 120 by 120 into 120 length. So it's like a 120 millimeter cube steel block hit with 25 meters per second velocity. So that velocity is going to impact. We are going to use a SI unit for this, so ton, Newton, millimeter second. So if I calculate what is my stress unit, will be Newton by millimeter square, which is nothing but MPa. Now the typical learning out of this will get is in Hypermesh how you define a general contact. So some general contact we'll learn how to do, hand caster condition, and then hit with initial velocity. Typical aluminum property 2.5, these are all generic property, so these are not really specific to any grade. These are generic property which you can use to solve this problem, but once you start building on this simple problem more like a strain, influence, plasticity and everything, then you start putting temperature dependent motor property, you can make a complex things out of this. So I'll also share how it looks like. So if we see, this is in Hypermesh how you define this friction and automatic general contact and initial velocity. So I'll also go to one more card, star section. So just want to check. So we'll try to do, so let me first check what is the thickness for this. So it's a 1.5 millimeter. So I'll delete this and we'll try to create. So now you are in Hypermesh v13. So you first user profile, go to user profile, Abaqus, and first load the Abaqus Explicit as a user profile. It may be OptiStruct or default Hypermesh. So you go and define first Abaqus Explicit. Once you define that, it will set up all Abaqus Explicit template. Now what I'll do, I'll go to here and first say aluminum square tube. I'm just going to create one component. So this is like a one bucket. We are not assign any property or material to this. It is just one bucket we have created. It will have all this geometry or element specific to name aluminum square tube. Now what I'll do, I'll put a F8 button and I say 0 0. So I'm putting a 0 0 coordinate. I've got a node here, then I say x100, I created another node, and then xy100, I created the third node, and then I created one more node on the y. Now I'm going to just I created the 4 node in 4 corner. This is just to create my geometry line. So I go to the geometry, I go to the line, I say first point, second point. I created the geometry here. So I created the geometry. Now this is only a 2D, so it is at 0 0, and I want this to extrude in negative z direction. So what I'll do, I'll say shift F4. So shift F4, I go to this line panel, I say display, I say display, and then I'll say duplicate original component, and I am going to move this by -300. So I got this at -3. So what I'll do now, I'll go first put O and check what is my mesh size. So my mesh size is 5 millimeter. I want 2.5 for this particular problem. So I put a 2.5 and then come out. I go to 2D, I go to rule option. So there is a multiple option within Hypermesh to do a meshing. So I go to the ruled and 2D, and then I select the first point line and I select the second line and I say create. So this way I create I'll just create first and second line. So I not selected properly. So I selected the first line, then I click on the second line. So now I almost created a tubular structure, but this is not connected. So if I say F5 and try to mask element, say by attach, it is not completely attached. It is only at interface, it is not connected. So I need to first merge this. So before merging this, we want to check what is the minimum element length. So once we understand minimum element length, below that length we can put and merge it. So I go to tool and then I say check element and I say 2D, check what is the length. So minimum length is 2.5, and then I put shift F3 and I say enable element display tolerance less than 2.5. I say 2 and say preview equivalence, and I see I am at the edge, it is getting merged. I say equivalence. So now I equivalence, but I want to make sure it equivalence everywhere, so there is no gap between the two adjacent elements. So I say shift F3 and I say element display and I say find edge. So I should get a edge. So I put a D now and then I say no, and then I say edge. So you see only edge which is at outer section. In between you doesn't see edge. So this is like a outer geometry, you see edge. That means there is a perfectly merged. So I do shift F3 and I say delete edge and I say D, and then I activate this element now. So there is element and geometry panel. If you put geometry, it will create all these lines. If you don't want lines, then just remove that geometry and element is on. Now we see the element there. Now this is only an element, it is not defined any thickness or material data, so it is just an element. So if I say card and select, this is like a S4 element set, but there is no property attached to that. So what I'll do, I'll first create a material. So I'm going to say aluminum AL and I say material, Abaqus material, I say create and edit. So what I want a density, I also want elasticity, I want to have a plastic data. I am going to put two plastic data. In case you have multiple plastic data like 7-8 different yield stress and plastic data, you start putting that. So since we have 2 points, so I'm just putting 2 points. So density we are going to put into 2.5 e power -9, and this is like 70,000 and 0.3 what I put, and I say 250 is yield, and around 300 we are going to put 0.1 as a plastic strain. So yield stress is 250 and 300 it is a 10. So we are just going to put something like a tangent modulus here. Now I'll just quickly put the thickness, and I want to select the section shell and aluminum property, and I'm going to put 1.5, and I don't want prefix. So now we created a property, we created a thickness, but still it is not connected here, so we need to first connect that. So I select the component, and then you select the aluminum. Now it is connected. So if you see material which is independent, then you go see the thickness. We put aluminum here which is connected to this material, and then once you connect that property to here, it is now the full card is got ready for this. So if you select, now everything is updated. Now let's save this. So I want to save these here as save as crash v2, because already I had done one, so I put v2. So now this is done. Now what I'll do, I'll create now, similarly I'll create now steel block which will be solid. So similarly I'll first put F8, put 0 0 0, then I say 120, and then 120, so let me put it here, and then X0. So I created a 120 block. I'll create a geometry, and I'll say create lines. I'm not interested in the stress level in the block, so block is just an impactor. So I'll create one more, something like a junk to have a shell here. So I'm going to put first shell, and I'm going to extrude the shell in one direction. So I say ruled, I select first line and second line I created, and I wanted something like a 5. So I'll just move this by 50 millimeter, or what I'll do, I'll delete this, I'll just refine it, or I'll say F12. I want this something like a 10, and I'm going to say element by collector. So just to reduce the problem size, I've done this. So now I'm going to make a, out of this 2D I'll make a 3D. So I first go and change to the collector to steel block. I say 3D, I said drag element by collector, and this is distance minus 120, and I say 15 element, and I say drag plus. So it just created a solid block for me. Now what I'll do, I'll say F2, and I'm going to delete this component. I don't want this shell component. So I created now the block. So block is created. I quickly create the steel property. So I'm going to have density and elasticity. So it's a 7.8 e power minus 9, and this is like 210 e power 03, sorry, and 0.3. So this way, now I'll create the property card for this. So block, so I say all, it will be not shell, it will be solid section, and the metal property will be steel. So create and edit, and it will be like, I don't want this prefix, it comes H property, so you don't want, you just remove it. So star section solid. Now I'm going to connect this to the block. So as soon as I connect the property to the block, now everything is now, I just save it. So we now got both component we have created. I need to still position it, so one end. So I'm going to position somewhere block here. So what I'll do, I'll just take a center point of these two. So I say F8 and then I say between, I want this point and this point. I just want a node there. So this is my position where I want to position this, and I take this face and again I put F8. I created this. So now I'll just move this. So shift F4, I say element by collector, I select this and I say N1 by N2. So this is my first position, this is my second position. So I don't want the geometry to be moved. So now I position my block there. It is just touching my face, so I just want to move a little bit back. So I select it and I say Z direction, I say -1. So I moved it back. So now my both component is made, both are positioned now. Now what I'll do, I'll first create a contact between these, so it will be automatic general contact with friction 0.3, and then we'll give a boundary condition here, end caster condition on this block. We'll give initial velocity 25 in Z direction. We'll create a step output blocks, and that's where we'll finish it off with run. So I go to the analysis, I interface, first I create friction. So I go to the friction, then I say surface interaction and I say friction 0.3. So I created 0.3 friction. Now I created the contact. So general contact I'm going to create. So contact, I'm going to, so I say contact inclusive all exterior. So just a minute, I'll just see. Yes, so contact inclusive all exterior we are done, and contact property assignment, I am going to assign friction property here. So first I created the friction property, then I gone to contact general. I say contact inclusive all exterior contact property. I am not I don't know which surface is going to come in contact, so I don't want to assign. So if I doesn't assign, it will take all surface. So no surface 1, surface 2, and then you have this surface interaction friction. So this way you done on the contact side. Now I'll quickly create one boundary condition here for end caster condition. So you see this load collector, you click on that, create no card image. I'll say something like, I'll select this and say end caster, and I'm going to say analysis constraint nodes on plane. So I just want to be selected everything on this. So I selected node on plane and I say create. So this created the end caster condition, and I'll do one thing, I'll create a node set for block. So I say analysis entity set, initial velocity name I given, and nodes by collector, I selected this and created. So I created a set of nodes, so I can assign the initial velocity to that. So then I go to again this, I say initial velocity, and I go to initial velocity. I need to give, and I say initial velocity using n set. So I say this, and then I want to be in third drop. I'll just check what is the direction. So it is in positive direction I have to give, and then I say 25000. So I define the initial velocity also. Now we made two blocks, two components. You define the initial velocity also on block, created a boundary condition. Now we'll create a two output block. First output block will be created for stress component, so field pre-select, and then either you give a time interval, so or number of intervals will be like, I'll just check what particular time interval I use. So we'll say number of 25, that will do. So number of intervals, so you will get 25 plot. I'll say element output and node output, and then I'll create one more output block. This will be for energies. So this will be for history output. Your variable will be please selected, and time interval I want to be have at least 100 points. So that's where I seen 0.002. So if you see, I'll show you. We are going to run it for 0.002, so we want to have at least 100 history plot. That's where we put 2 e power of 05. So this will get all your energy output. So if it doesn't give anything, like here you give energy output, you'll get all related to all energies, and you can see how the velocity is changing everything. So we've done this. Now we'll go to the load step, crash. I select end caster condition. Initial velocity is actually it's not actually in the step, it will be precondition. So selected, you selected both output block, and I say create and edit, and then you put nljom on, name crash, and then we need to say dynamic explicit 0.02 seconds. That's where actually we want to run this. So we almost done everything. I'll say save, and we are going to export it. So we'll just export it, and we'll see how the crash looks like. So v2, and I say inp, save it and export it. We'll quickly check this inp file in text pad. So you got node, then you got element, initial velocity, then you got property data. So I think it's about to go. So let me so I already gone to that folder. I say abq6145 because I have Abaqus 6.145, so that's our I put, and then you say crash v2, paste, and then CPUs I want to use 4 and interactive section, and then I put a enter. So it will, so it's started going into So it go to the preprocessor, so it gone to packaging. So it just started. So run got through, so we need to just wait till the run get over. So I'll put new here. So as soon as we get it something, so we just got one, so let's check how it looks. It just started. So if I slow down it, so just couple of step done. Two steps done. So let's wait till we get enough steps, and then we can start on the post processing side. So meanwhile I just pause the. So just now the run got completed, so it took some time. I just again applied it, and I say mesh mode. Let's see how we see it. So this is how we see structure get deform. So we'll also put a stress plot. We'll put a stress plot, and then probably we'll take a section cut. So you go here and then put a section cut, and then you say reverse. So you see how. So you can see now how that is actually get deform. You see the contact getting in contact with self contact. I'll also do one thing. I'll just put one more window here side by side, and we can quickly measure how is the velocity reduce. So I'll just take a one node here somewhere and measure what is the velocity get. I'll say, so I need to first go and put velocity counter plot, and so displacement acceleration, I need to see the velocity plot, and then probably I need to select this, and I select one particular node, and I say, and then I say create curve into the existing second window. 1 minute. So you can do a lot of things, but so I say not distance between nodal counter, and then you say we can see how it select one not from the list. Okay, so we can right now look into the stress plot, and let's see how, and then I'll just, so this is how we can done the crash problem. You can do multiple things. You can plot energy plot how, and typically the kinetic energy will go down, strain energy goes up, and you can also see the area. So you can also go and check equivalent plastic strain, how which particular location it is getting accumulated. So this was a quick video guys on Hypermesh tutorial using crash test. I hope you like this video. Don't forget to like us and subscribe us. There are many more videos to come. Thank you. Bye bye.